All right. So here's how the problems go. First one, the amount of coffee that people drink per day is normally distributed. What does that word mean, normally distributed? It's a bell curve, right? The amount of coffee people drink. So some people drink a whole bunch of coffee, some drink a little bit, but most people are around the middle, whatever that is, the average. Thus you get the bell shape. With a mean of 14 ounces. So what does that mean there? What are we saying? Average person drinks 14 ounces of coffee per day. Standard deviation, 6 ounces. Remember what standard deviation is? What's standard deviation? Average distance from the middle. Average, so this has to do with spread, doesn't it? So, the average person drinks 14 ounces of coffee a day, but not everybody's average. Some drink more, some drink less. How far are people off of that middle? Typically by 6 ounces, either more or less. That's the standard amount they're off the middle, by 6 ounces. Okay, now so far we could have done that in chapter 6. So far this is nothing new from last night's homework, right? Here comes the new part. And this will be super similar. You won't find this hard at all. We're going to use the same 2 formulas. It's going to be all about Normalcdf and inverse norm on the calculator. Again, here's the new part. 35 randomly selected people are surveyed. Round all answers to 4 places. So we're grabbing not just one coffee drinker at a time, but we're grabbing 35 coffee drinkers, and we're going to talk about the average of the 35, just like we talked about the average of a bunch of dice rolls. Here we go. What is the distribution of X? And then question B is going to say, what's the distribution of X bar? So, are you noticing those differences? It's X and X bar. What does it mean when we have a bar on something? Yeah, it means mean or average, doesn't it? It's the mean. That's the average. So what they're saying to me on part B is they're saying, what's the curve going to look like for the averages? And what did we just see with that dice program? What happens when you do average of 10 dice or 2 dice? It becomes a bell. And so that's what they're saying here. It's normally distributed, but so's the original. So this is one at a time, one person. I should say one. It's like rolling one die at a time, but we're talking about one person and how much coffee they drink at a time. And the X bar is the mean, the average of 35 people and how much coffee they drink on average. So you're seeing the differences there. They're going to do this on every question. So the plain X means the one person at a time, like the one die at a time, rolling one die at a time. And the X bar means the average of 35. They told me 35 people per time. So, okay, so what? What does that mean? Well, when they give me this normal distribution, the big N here, they're saying, okay, the one at a time, is that normally distributed? Now, for our dice, it wasn't. Remember, when we started with one die at a time, it was uniform, wasn't it? It wasn't a bell curve. But they told me right here that even the one at a time is. Right here. People drink per day is normally distributed. So even the amount of coffee one person at a time drinks is normally distributed. And first we put the average. Right? This is always the mean. And this is always the standard deviation. So what's the mean? 14 ounces. That goes right there. And we had that in last night's homework, right? Where we had to do this. It's the same thing. Okay, I'll quit talking it to death. And 6 is the standard deviation. So just like last night's homework, just mean 14, standard deviation 6. Now the new part, though, is the X bar. The average of 35 coffee drinkers. That's what they're asking me about right here. So is that also going to be normally distributed? For sure it will. The average would be normally distributed even if the original wasn't, huh? Is this making sense? No, let's move on. We'll come back to that. So what's going to be the middle for the averages? Right here I'm supposed to put the mean, and right there the standard deviation. What did you see on the dice problems when I was doing the simulation? Did the middle ever move? No, the middle stayed right where it was at. Even thousands and thousands of rolls, 10 dice, 20 dice, whatever. The middle didn't move. The average was the average. That doesn't change just because you grab more dice. So that doesn't change. The middle's the same. It never will change when we grab more dice or more people. Whatever the average amount of coffee is for one person, it's going to be the same average if you grab 35 people. But what will change is the standard deviation, because that's the width of the curve. And we saw that, right? When you grab more dice per time, more coffee drinkers per time, you make that bell curve become more narrow. You make that standard deviation become smaller. So the new standard deviation, the formula is right there. The new standard deviation is the old standard deviation, the standard deviation for just one coffee drinker, divided by the square root of n, where n is the number of coffee drinkers, in this case, 35, that you're taking the average for, 35. So it's going to be, what was it? Was the old 6? The old standard deviation was 6, divided by the square root of 35. Grab your calculator and find out what that is. That'll be the new standard. 6 divided by 35. I'm getting 1.014. How far do they want me to go? 4. Okay, so I need one more, huh? 2, because 185 rounds 2. 4 decimal places. Y'all getting that? So that goes right here. 1.0142. Notice it went down, huh? The standard deviation, the amount of spread went down. That's exactly what we saw in the simulation. That when you grab more dice, the spread goes down. Okay, so now we're ready to answer the questions. Part C. What is the probability that one randomly selected person drinks between 13.5 and 14.1 ounces of coffee per day? So how are we going to do that? That's what we did in last night's homework, huh? Yeah, so that's either going to be normal CDF. Let me get a fresh screen for us here. That's either going to be normal CDF. So let's draw it. It'll help you to draw the normal curve, so I'm going to draw it. And I always put the middle on. What's the middle of this normal curve? Yeah, the 14. Yeah, the average, at least on my problem, is 14. Okay, and now where does the 13.5 and the 14.1? Well, 13.5 is a little bit to the left. 14.1 is just barely to the right of 14. And they're wanting me to find that, aren't they? So that's what we did in last night's homework, right? We would just draw exactly what they're saying. They're saying what portion of the whole curve is between 13.5 and 14.1. So the question is that a normal CDF, or is that going to be an inverse norm on our calculator? How do you know? Remember the difference? Normal CDF is when they what? Ask for an area or a percentage. Yeah, area, percent, or decimal. Right. And an inverse norm is when they give you an area, percent, or decimal. Exactly. So which one are they doing on this? Are they asking me for an area or giving me an area on this picture here? Yeah, because if they gave me an area, where do we always see the area numbers? Up here, huh? They'd be like 2317 or whatever. Area numbers are always in the top. Remember that? And there's no area number up there in the top. So they're not giving me an area. They must be asking for an area. So they want normal CDF. Remember how normal CDF works? You put in there left edge, right edge, mean, standard, right? Left edge, right edge, mean, standard. So hit the buttons on your calculator. And it's the left edge, right edge of the piece of shading. So there's the chunk of shading. There's his left edge. There's his right edge. So his left edge, 13.5. His right edge, 14.1. Right, I don't use the 14. I use the 14.1. That's the left and right edge of the chunk of shading. And then the mean, they already told me the mean is 14. Standard deviation is 6. Now I'm just going to use, 6. I'm just going to use that standard deviation for now. Why? Because part C is one randomly selected person. You notice that? That's the whole game they're going to play in this chapter. They're going to give you first a question for one person, one die, and then next question they're going to say, now for 35 people, do the same exact thing. The calculation will be identical, except the standard deviation you'll have to divide by the square root of n. That'll be the only difference, because it's still normally distributed, it's just more narrow. All right, hit the button. Somebody got that? What's the number on the calculator say there?
2305.
23 what?
05.
23.2305?
Yeah, you got pretty close with the 23.7 actually.
I can just tell. No. 0.2305. So is that good? Is that coming out for you? Now, question D. Same question, right? Notice it's even got the same two numbers. Whoops, I'm looking at the wrong one. 13.5 and 14.1. That's the same region on the normal curve. But the difference now is it's for 35 people. You're saying, what's the chance that the average, right? For 35 people, find probably that the average coffee consumption for 35 people is in that zone. So what do? Everything's the same. It's still going to be normal CDF. It's need a little more room here. Everything's the same. Left edge. Let me make sure I have enough room. Normal CDF. Left edge is still 13.5. Right edge is still 14.1. The mean is still what it was. Remember, the mean did not change, right? Remember back here when we first did that? The means are the same, aren't they? So the mean is, the middle is still 14. And now the standard deviation will be different when you have a group average. What's it going to be? It's the old one. And by the way, you don't even need to, I know we figured it out somewhere back here. I'm not even going to do that. Make this as easy as you can on yourself. Question?
For answer C, I
Yeah.
got something different. Yeah.
Oh. What you guys getting there?
0.039855.
039,855. So 0399?
Yeah.
Okay, sounds like that.
Oh, yeah, I did miss that.
0399. Thank you. So let's finish up this one. So normal CDF. So 13.5. Left edge, right edge, mean. And now, what do we do for standard? Just put the old standard, which was 6, and literally just type this in. Let the calculator do the work. Divided by, hit the square root button. Do you know where the square root button is on your calculator? It's on the left edge above x squared. Left side, right in the middle, above x. You got to hit second and the root button because it's above. Anything above a key, you got to hit second and then that key. You know what I mean? So second square root of 35. There you go. Don't even need to hit closing parentheses. Just hit enter. So I'll do it. So it's going to be 13.5, comma, 13.1, 14, comma, and it's 6 divided by second square root of 35. So I'm getting 0.2283. Y'all getting that? 2283? Is that making sense? The only difference, it's exactly what we did in the previous part C, except right at the end for the standard deviation, we take the old standard deviation of 6 divided by second square root 35. The new standard deviation is the old divided by the square root of the n. That's all the change. Is that okay? We good, Samantha? General questions on this one, though? We getting the 2283? Okay. So I'm going to go on to part E. Looks like you guys are off and running. All right, I'm on part E. Oh, yeah, there's one other key fact I've not told you. You'll need to know this to answer the questions. For part D, is the assumption that the distribution is normal necessary? The answer is no, because n is greater than 30. Basically, here's what the central limit theorem says. The CLT, the central limit theorem, which basically says when you grab group averages, it's going to make it a bell curve and tend towards the center. It says when n is greater than 30, it automatically makes a bell. or a normal distribution. That's what the central limit theorem says. Now, we saw that it even starts to do that for a group of 2 dice or 10 dice. But they're just wanting to give a big number to guarantee it. They're saying as long as you have 30 or more, for sure, it'll make a bell curve. That's the rule of thumb, so to speak. So basically, anytime n is bigger than 30, our n was 35. That's our n. That's how many. We were grabbing 35 coffee drinkers at a time. Anytime you have more than 30, then you don't need the original distribution to be normal. Now, it was. They did say, even for one person, it's normally, right? Remember, it was a bell even for one person. It wasn't for the dice. When we rolled one die at a time, that was uniform. That was level. But it turned into normal when we started grabbing groups, right? That's the point. If you have more than 30, no matter what the original distribution was, it'll make it a bell for groups more than 30. So what they're saying is, hey, did you need to know that the original one was normal? And we're saying, no, we didn't even need to know that because we had more than 30 coffee drinkers. It was going to make anything bell. I did not need to know the original was bell. Now, if this was less than 30, if this was only like 10 coffee drinkers, you wouldn't really know. There's no guarantee that if you just take 10 or 20, something less than 30, that it's going to really make it bell. I mean, it does. We saw it with the dice. But they're being really picky here. They want to guarantee it's going to be a bell curve. And so there's no guarantee unless you get over 30. So basically, whenever we have an n less than 30, the answer is going to be no. Yes, we did need to be told the original was bell, or we wouldn't know the new one's bell. Am I making any sense? I'm kind of talking around the issue. More than 30 makes anything bell. How about that? More than 30 makes anything bell. All right. So we'll use that. Let's go on to part F.
What if you have less than 30?
So if you have less than 30, it won't make anything bell. Right, if you have less than 30 drinkers, at 10 drinkers or something, then it doesn't, I mean, even though we saw it usually does, there's no guarantee that it'll make anything bell. Therefore, you're not going to be able to use the thing on the calculator, normal CDF. That's only for normal distributions. So if you only have 10, and there's no guarantee that it's going to make it bell, how can you be using the normal stuff? You would need to know the original was bell as well. That's their point. I'll say that again a few times as we go. They're going to ask that question every time. So, all right. So, greater than 30, the answer is always no. Less than 30, the answer is always yes. All right. Now we need to find Q1, Q3, and the IQR. Let's do that. Get a fresh screen here. So, can we find Q1? What does Q1 always mean? Yeah, first quartile, right? So if we lay out a bell curve here, here's the middle. So this is like Q1, it's the end of the first quarter. Right? It's breaking the whole bell curve into 4 quarters. So this is Q1, this is the first 25%, like the first 25% of a football game. The next 25% to halftime. The next 25%, that's the end of the third quarter. And the last 25%, that's the fourth quarter of the game, right? So we good there? So Q1's the end of the first quarter. Q3 is the end of the third quarter. So how are we going to find Q1? Well, we're either going to use normal CDF or inverse norm. Right? Remember, normal CDF is when they ask for the area, percent, or decimal. Inverse norm is when they give us area, percent, or decimal. So which one is it? On that picture, it's all about the picture, right? Are they asking me for area or giving me area? Yeah, there's a whole bunch of areas right there, aren't there? The numbers up above are always area, aren't they? Right? You know what I mean? This is, you can put it up there if it helps you. So that's area. Now what area? What area? Well, remember how, so we're going to use inverse norm. Everybody good? Inverse norm for this part because they're giving me area. And how does the inverse norm function work? Let me write it over here. Remember what's in inverse norm? Area left and mean and standard. Right? So what's these? So it's going to be inverse norm. Area to the left. What area is to the left of Q1? 0.25. 0.25. What's the mean? Same as it always was. 14. Now, what's the standard? Are we talking about the group of 35? Or are we talking about individuals? That's what you want to keep straight throughout this chapter. They're going to keep going back and forth between individuals and groups. Individual, group, individual, group. And whenever they do a group, the only difference, everything's the same. The only difference is for a group, you just divide the standard deviation by square root of n. That's the only difference at all. So part F, is this a group or an individual? Yeah, 35 coffee drinkers. So I take the standard deviation, the original, the old one was 6, and go divide by square root of 35. That's the only difference. Just divide by square root of 35. That's the only difference of tonight, basically. It's nice. It's like a night off. It's the same thing. Did you want a night off of stats? Kind of like that. So I'm getting 13. How many decimal places? 4, I guess? 13.3159. Did y'all get that? No? Nobody got that?
Yeah.
Okay, good. And now can you find Q3? They want Q3. And then IQR will just subtract them, right? Can you get Q3? So it's going to be super similar. So I'm going to come in here, inverse norm again. And I'm going to go area left, mean standard. So for Q3, end of the third quarter in the football game. So if you're at the end of the third quarter in a football game, how much of the game has already gone on before you? 75% of the game? At the end of the third quarter, huh? So the area to the left, 0.75. The mean is still 14. Standard, it's going to be 6 divided by square root of 35. Somebody got that number? 14 point something, I bet. 6841. Thank you. 14.6841. So that's the Q3. And then the IQR, you just subtract them, right? Just subtract them on your calculator. So whatever that is. I'm betting it's 1.3 something. 1.3 what? 3651. Thank you. And there's question number 1, and they're all the same. We'll do a couple more, but it's pretty much the same every time. So that makes sense. So it's exactly like last night's homework. The only difference is when they have a group, you divide the standard deviation by the square root of the group size.
Okay, so going back to E, I clicked it and all my calculations were correct.
Right.
Saying that the answer is yes.
What was your sample size?
10.
So yours is under 30. So for under 30, you need the original assumption. Is that making sense? So let me write that clearly. So when n is greater than 30, it makes anything, let's put it that way, makes anything become a bell curve, right? So there's no need to assume the original was a bell. Is that making sense? Whereas when n is less than 30, there's no guarantee that it will make it a bell. There's no guarantee. The guarantee is only when you're over 30. Only over 30 in your group. So if you have less than 30, there's no guarantee that it will make it a bell, and we need everything to be bell, right? Everything we do on this thing is assuming it's a bell curve. right? The thing's even called Normalcdf. It assumes you're talking about a normal curve. So if there's no guarantee that it's going to make it a normal, then so we need original to be Bell. We need the assumption that the original was a Bell. Does that make sense? How the questions are going to come at you? So if you're simply about your sample size, if it's more than 30, it makes anything Bell, so you don't care what the original was. Doesn't matter. We don't need to assume anything about the original. But if you're less than 30, that doesn't have the guaranteed power to make anything a Bell. So then you would need to be told the original was a Bell as well to be able to assume the groups are Bell.
Are you talking about 30 just for this question, or?
Everyone. That's the central limit theorem. That is the CLT. He says, if you have more than 30, I guarantee I'll make it a Bell. That's what the central limit theorem guarantees. So that's for the whole chapter, every problem. Yeah, not just good question. Not just this particular question. That's the guarantee. It's like the Midas guarantee, but it's the central limit theorem guarantee. For groups bigger than 30, it'll make them Bell, no matter what they were before. Group averages more than 30 will be made Bell. So in that case, you don't care what the original was. But if it's less than 30, you do need the assumption that the original was a Bell, because it won't make anything Bell, necessarily. It really will, but no guarantee. 2. So number 2. Suppose the age that children learn to walk is normally distributed with mean 13 months and standard deviation 1.5 months. So that means the average child learns to walk about 13 months. I was just at something last night where the parents were telling me about the little, I think he was 10 or 11 months. He's getting close to walking. It's been a lot of years since I've been in that zone. Since I had kids in that zone. Might all walk now. 7 randomly selected people were asked what age they learned to walk. Does anybody really remember that? I'm sure. What age? Do you? Do some of you remember? Okay. So what age they learned to walk? Round all answers to 4 decimal places where possible. All right. So here we go. What's the distribution? So again, we have the regular x, and down here we have the x bar. This is what they're going to do every time. So the regular distribution, we're always going to start with the mean and then the standard deviation. So the mean is just going to be 13, as they said right there. The standard deviation is 1.5, as they said right there. No big surprise. What about for the x bar? What about for the averages of groups? What's going to change? Only the standard, right? The mean's the same, but the standard deviation now will be 1.5 divided by the square root of what? At least on my problem, 7. We're taking 7 kids at a time, or 7 people. 7 people at a time, and figuring out and taking the average of the age they learn to walk. So square root of 7. So 1.5 divided by the square root of 7. I'm getting 0.5669. 4 decimal places. There we go. Now on with the questions we go. See how the questions are going to be the same every time? See what is question C about one person or a group?
One person.
Yeah. One randomly selected person. And then question D, 7 people. So that's what they're going to do every time. That's the game they're playing. One person, group of people. One person, group of people. And it's all the same stuff, Normalcdf, inverse norm. Only difference is, if it's a group, standard deviation divided by square root of n. It makes it central. So I'll crank it out. So part C is again going to be which one? Therefore, I'm going to draw C. Here it's a normal curve. It's a bell curve. And I always put the middle on. What's the middle of the bell curve? Mine is 13. And they're asking between 12.5 and 13.5. So over here, 12.5 over here, 13.5. They want the area in between. So they're not giving me an area. There's no area number up in the top there. So they're asking me for the area. So that's going to be normal CDF. So I'll do that. Come up here. This one's going to be normal CDF. And it'll be the mean. No, I'm sorry, not the mean. It's left edge, right edge. The left edge, the right edge. So it's going to be 12.5. 13.5. The mean is 13. The standard deviation is 1.5. I just keep the normal standard deviation for one person, right? Hit the buttons on the calculator. And then for part 2, for part D, it's again normal CDF from 12.5 to 13.5. Same mean. And the standard deviation, 1.5. divided by the square root, in this case, of 7. Because my group size is 7. Hit the buttons on the calculator. Is that good? It's all easy? So we're good there. I'll come down to the Q1, Q3, IQR. And that's going to be the bell curve again. The middle is whatever it was, 13 months. And Q1 is the first quarter. And Q3 is the third quarter. 0.25, 0.25, 0.25, 0.25. So they are giving me the area, so that's inverse norm. And that's area left, mean, standard, inverse norm. Area to the left for Q1, 0.25. The mean is 13. And for the standard, you want to ask yourself, am I talking about a group or an individual? On part F, we're talking about the average for 7 people. So the mean is still 13. Oh wait, I already did that. Standard deviation then is the other one was 1.5. 1.5 divided by the square root of 7. Hit the buttons on your calculator and get Q1. Q3 is the same way with 75% instead of 25%. All right, so we're good there. I'm going to go dot, dot, dot. It's the same as number 1 was. Move right on to number 3. Here we go. Now on number 3, they're only asking me for the X bar. Notice, they're not asking me for the distribution of just the individual X's. They're just saying, hey, how about those averages? What's it going to be? Well, you know the deal. It's mean here, and it's standard deviation divided by the square root of n. Because for a group, it becomes more central, doesn't it? So what's the mean? 194. What's the standard deviation? It's whatever the old standard deviation was, right there, 7.3. Divided by the square root of 11. So whatever the calculator says on that. I'm getting 2.2012010. All right, and then it says, question B, for the group of 11, so we're talking about the group now, not the individual, find the probability that the hand length is more than 193. Remember, it's just like last night's homework. You want to draw a bell curve that fits what they're saying. So draw a bell curve. You always want to put the center on. The center, the mean is 194. So 194 is the average hand length. And now I'm going to put on the shading that they're talking about, that they're referring to. What are they saying? More than 193. So where's the 193? Is that to the left or the right of the 194, which is the center? 193 is just a little smaller than 194. So it'd be over here just a little bit. And then which way does the shading go? It says more than 193. So that's shading to the right, isn't it? If they said less than 193, I would have went to the left, huh? Is that making sense? We good with that? So shading, so greater than, more than 193. All right, so now, are we going to do normal CDF or inverse norm? Are they asking us for an area or giving us an area? Is there an area up here? No, the areas are always written at the top. There's no area up there. They're not giving me an area. They're asking me for an area. So that is normal CDF. Normal CDF. And how do we always do that? Area to the left, comma mean, comma standard. Okay. So normal. Okay, so what is the area to the left? Here's my spot. My spot's 193. What's the area to the left?
I thought inverse norm was area.
I'm being totally crazy. You're totally right. I'm just losing my brain. You're totally right. Left edge, right edge means... Just kidding. I was testing you. Good job. Thank you. All right. It's been a long day for me, I guess. Left edge, right edge mean standard is normal CDF. So the left edge is the 193. What's the right edge? Yeah, right over here. That's remember they go forever right and left. So if the shading goes forever to the right, that's 99999. That's just our way of saying forever right. If the shading happens to go, this one doesn't, but some of them do. If the shading happens to go forever left, what do we do for that? Negative. 99999, right? Because negative numbers are to the left, positive numbers to the right. Forever positive, forever negative, left to right. Okay, so the right edge is a bunch of nines. 5 nines is safe. The mean, 194. Now, what do you do for the standard deviation? Is this a group or an individual? That's what you always want to be asking yourself throughout this chapter. Group or individual? Yeah, this is a group of 11. So I'm going to take the standard deviation 7.3 and divide by the square root of 11. That's what the central limit theorem says. If you have a group, it centralizes things. It makes the standard deviation divide smaller, become smaller. It piles the sand into the center. Hit the buttons on the calculator and you'll get that. Part C is third quartile. That's the same kind of thing. How about part B? Or part D? Is the assumption of normal necessary on this problem? Yeah, for my example, I had 11 individuals. Is that enough for the central limit theorem to guarantee to make anything a bell? No, that's not enough. So we need the original to have been a bell. Or we can't be using this normal CDF thing, right? The final thing would not be bell unless the original had been, right? This isn't enough to make anything bell. So yes, we do need the original assumption that the original was a bell. Or we couldn't be assuming bell at the end. Because 11 is not enough for the central limit theorem to guarantee to make anything bell. We good on that one? Okay, so number 8. The amount of pollutants that are found in waterways near large cities is normally distributed with mean, standard. 15 large cities are studied. Here we go. Okay, so what's the distribution of just plain X? Well, you know the deal. It's mean. It's a normally distributed bell curve. They said so right here. Normally distributed. That's how you recognize these, by the way, on the test that we take in a week. Is you'll see the word normally distributed. You go, oh, all right, it's a bell curve problem, normal CDF, inverse norm. So the mean is the 8.9. The standard is the 1.3. And now for x bar, you know the deal. For x bar there, it's the same mean, but the standard is 1.3 divided by the square root of 15. 15 cities. Hit the buttons on your calculator. Well, I'll just leave it, whatever that comes out. Question C. Coming on down to question C. What is the probability that one, that's just one, right? It's all about, is it one or a group? That's one. Randomly selected city waterway less than 8.6. So draw the bell curve. Always put the middle on there. The middle is 8.9. That's the average amount of pollutants near a large city. And they're saying, what's the probability that it'll be less than 8.6? Can you do that real quick? What we need? So they are saying what? Less than 8.6. So 8.6 is somewhere to the left. Right? It's less than 8.9. And now which way am I going to shade? Am I going to shade to the left or to the right? Yeah, at least on mine, it said less than 8.6. So that would be to the left, huh? Lesser stuff is to the left, bigger stuff is to the right. So there we go. So am I going to do, what is it, Normalcdf or inverse norm? Are they asking me for an area or giving me an area? Yeah, if there was an area, it would be up here like 0.3721 or something. There's no area up there. They're not giving me an area. They're asking me for an area. So that is normal CDF. I'll try to do it right this time. Left edge, right edge, mean standard. Yeah, this one is one person, huh? So this will be normal CDF. Whoops. So left edge. Now, what is the it's always for the chunk of shading, isn't it? What is the left edge of this chunk of shading? Negative 9. Yeah, it's left forever, isn't it? Negative a bunch of 9s. That's the left edge. The right edge is the 8.6, huh? Is that good? So this, that's why I did this one, because it did this unique thing where the shading went left forever. So that's the negative 9. So that's the left edge, negative a bunch of 9s. The right edge is the 8.6 right here. The mean is whatever it is, 8.9. The standard is 1.3. But am I going to divide there or not? Well, at least on part C, it's just for one person. So I'm not going to divide. And then when you get to part D, they're going to do the same question for 15 cities. Then it's exactly the same thing. Just put a divide by square root of 15 at the end, huh? So much the same every time. Dot, dot, dot. That good? The rest is the same?